Hi everybody, today we're going to start talking about acceleration. We've been talking about motion in class, and we've classified motion as two types. Constant motion, where we are changing our position by the same amount every time interval, and non-constant motion, where we are not changing our position by the same amount every time interval. And we've said that essentially if we're moving in non-constant motion, we must be changing something about the way we're moving, and we must be accelerating. So our objectives for this lesson are to be able to define and calculate acceleration, and to also set up the groundwork and the basic information that we're going to need to solve problems involving acceleration. So let's define acceleration first. Acceleration is defined as the rate at which an object changes its velocity. An object is accelerating if it's either changing its velocity by speeding up or slowing down when moving in a straight line. That's important, that straight line part. Remember I said when we start to talk about motion in class, we're going to be looking at the motion of an object as it travels in one direction only. Because velocity tells us not only the how fast, but in what direction. If we take any change of direction out of the changing motion, meaning an object doesn't turn around or change its direction during its motion, the only way it can be changing its velocity is by changing its speed, essentially speeding up or slowing down. So it sort of simplifies our problems, which is why we're going to look at motion first in just a straight line. Acceleration, just like velocity, is a vector quantity, so it has a size, meaning a number, how big is it, and it has a direction. The direction is very important because if we start talking about acceleration as both speeding up and slowing down, we need some information to tell us which is happening. Is my object speeding up or slowing down? And that direction information is what's going to help us determine that. Acceleration is the first vector quantity that we're going to start to work with that doesn't have a different name for its scalar or size of. If you remember when we started talking about distance and displacement, especially when we're traveling in a straight line, we said distance is the how far, it's a scalar quantity. Displacement is the how far and in which direction, it's a vector quantity. When we talked about speed and velocity in one direction, we said the speed is the how fast. The velocity is the how fast and in which direction. So we had different names again for the scalar and the vector quantities. When we start talking about acceleration, we don't have that name difference anymore. So as a result, when we talk about acceleration, we could be referring to the size of, or we could be referring to the size of and the direction. And you have to make sure that you know when you have to incorporate that direction information in your problems. Let's look at describing acceleration by using some objects in motion. Let's look at this car. It's moving with a constant velocity of a positive 10 meters per second. You may have said, how do you know that? Well, we can look at the motion diagram. The motion diagram tells us we're changing our position 10 meters, the same amount every second. So we could figure out our change in position over our change in time, 10 meters per second. We could have also graphed our position versus time information in the graph here shown. And we would have noticed that we got a nice straight line with a non-positive slope as our graph. That indicates that we're changing our position at a constant rate, or we're traveling at a constant velocity. If we wanted to determine the size of it, we would find the slope of the line, which is 10 over 1 meters per second, and we would say it is positive because that line has a positive slope. If we now graph that velocity versus time information, like over here in this graph, you can see that we get a nice horizontal line with slope equals 0 because the velocity never changes. At every second, the velocity remains the same. So just like when we talked about our position versus time graphs, when our position did not change or we were not moving, we got a horizontal line on our position versus time graph, or a line on the position versus time graph with a slope of 0 indicated we were at rest. The slope of the velocity versus time graph tells us something about how we're changing our velocity. So the fact that we're not changing our velocity at all tells us that we have no acceleration. So when we look at these graphs, we see that we have constant velocity, no acceleration, and that makes sense because we're moving in constant motion. Now what if we take a car that's moving in non-constant or accelerated motion? Again, you may ask, how do I know? Let's look at our motion diagram here, and we can see that we're changing our position more and more each subsequent second. And as a result, in order to be able to change our position more and more, we must be speeding up. If we looked at our position versus time graph, we would see that we do not have a straight line indicating a constant velocity, but instead we have a curve indicating a changing velocity. If we wanted to then take that information and graph it in a velocity versus time graph, we would get something that looks like this. If at every second we calculated our velocity, we would be able to graph it, and then we would get a nice line indicating a constant rate of change of velocity, where we could go out and calculate the slope of the line if we wanted to. And this guy turns out to be 2. The slope of the line is 2 meters per second. And that's telling us something about the acceleration, how that object is changing its velocity with respect to time, that definition of acceleration. So the slope of the line of a velocity versus time graph gives us information about the acceleration of the object because it's indicating the change in velocity with respect to time. So to determine the acceleration, all we need to do is calculate the slope of the line. And then to determine the direction of the acceleration, we look at whether or not the line has a positive slope or a negative slope. So let's look at the 3 velocity versus time graphs that we might see in our study of motion to understand acceleration. The first one here, the graph of our velocity versus time graph, is a horizontal line. The slope of that line is 0. It indicates that the acceleration is 0 and the motion is constant for the object. The velocity is not changing. Here we have a line on our velocity versus time graph that has a positive slope. So that tells us that the velocity is changing. The direction of the acceleration is positive, which means that we are speeding up. Our velocity, the size of it, is getting bigger and bigger and bigger as we go on with time. Here is where we look at a velocity versus time graph where we have a line where the slope is negative. In that case, it indicates that the direction of the acceleration is negative. And what does that mean? Because we're not used to saying negative acceleration. Well, if we look at this velocity versus time, it tells us that the velocity is decreasing or getting less and less and less as we go on with time. So as a result, this is an indication that our object is slowing down. All right, what about the units of measurement for acceleration? These are odd, probably something that you want to get used to. So let's look first of all at our slope. Our slope, remember, is change in y over change in x. So let's look at our units of measurement. On our y-axis, we have the units of velocity, which are meters per second. On our x-axis, we have units of seconds for time. And it tells us that our slope tells us we change so many meters per second every second. You remember back from algebra, this is not the best ratio. We want to clean it up. So we're going to multiply the bottom by its reciprocal. That's going to give us 1. And if we multiply the bottom by its reciprocal, we have to multiply the top. Those units then become meters over a second times a second. And remember, when we square anything, we multiply it by itself. So as a result, we end up with units of acceleration as meters per second squared. It just means meters per second every second. So in order to really understand the direction of acceleration and what it means to our velocity, we have to make sure we understand all these positive and negative signs. So first, let's look at the signs for velocity. Velocity is considered positive whether it's moving away or towards the origin if it is in the positive portion of the velocity versus time graph. All right, so if you look here, even though the slope of this line, this one is positive and this one is negative, that's telling us something about the acceleration. The velocity values themselves are all within the positive range or the positive y range of the graph. So as a result, they have positive values. Over here, the velocity is negative, whether it's moving away or towards the origin, because it is in the negative portion of the graph. So again here, the slope of this line is positive, the slope of this line is negative, but that has something to do with acceleration. When we're looking at a velocity versus time graph, the area in which the velocity is graphed indicates whether or not it's positive or negative. Now, if we add in the information for acceleration, that's going to tell us whether or not we're speeding up or slowing down. So, whether or not your velocity is positive or negative, as you see here, if the velocity is increasing in that same direction as time goes on, you are speeding up. So look at this. Velocity is getting greater in number, all right, in the positive direction, or velocity is getting greater in number in the negative direction. Remember, the number tells us the how fast. So as a result, these guys here were speeding up. If we look at this, whether your velocity is positive or negative, if it is decreasing in that direction, you are slowing down. So again, here you have a positive velocity, but as time goes on, the number is getting less. The size of, the speed is getting less. So as a result, you are slowing down. Here, you start off with a larger negative number, meaning the absolute value, the size of the number was bigger, and it's getting less and less. So as a result, you're just slowing down in that direction. So here's the rule of thumb about velocity and acceleration to tell us about motion. If velocity and acceleration have both the same sign, meaning both positive or both negative, you are speeding up. So you see here, my velocity is positive, the slope of my velocity versus time graph, which indicates the acceleration, is positive. Velocity negative, slope negative. These guys are speeding up. Here, positive velocity, negative slope, negative acceleration. Negative velocity, positive slope, positive acceleration. And these guys are slowing down. Alright, so acceleration in a nutshell. Acceleration is a vector quantity. It has a direction associated with it. That direction is going to tell us all the information that we need about whether or not an object is speeding up or slowing down as it is accelerating. So the direction of the acceleration vector depends on two things: whether the object is speeding up or slowing down, and whether the object is moving in what we call the positive or negative direction. The rule of thumb to remember is if the object is slowing down, then the acceleration is in the opposite direction of motion or velocity. So let's look at a quick example given this velocity versus time graph. Here, let's look. Is the first question, is the object moving in the positive direction? Yes, it is. And how do I know? I know it because the velocity is always in the positive range. I'm always changing my position in the positive direction if my velocity is in the positive range. Is the object moving with constant velocity? No. If it were moving with constant velocity, this would be a horizontal line and I would have no acceleration. The fact that I have a non-zero slope on my velocity versus time graph indicates I have acceleration. Is the object moving with negative velocity? No. In order to move with negative velocity, it has to be in this range of the graph. Is the object moving with constant acceleration? Yes, because it's changing its velocity at a constant rate. That's what the straight line indicates. Is the object moving with positive acceleration? No. And that's because the slope of this line is negative, so it indicates a negative acceleration. Is the object slowing down? Yes. Its velocity is positive direction, and it's getting smaller and smaller and smaller in size as time goes on. The velocity is positive, the acceleration is negative, they're in opposite directions, and as a result, we are slowing down. Our last piece of information is the equation for solving average acceleration. This is just very similar to the average velocity equation that we had. Average acceleration, the symbol for acceleration is lowercase a, is simply equal to the change in velocity over the time interval. We have to remember that the change in velocity always indicates a final value minus an initial value. That has to be in that order so that we can determine whether average acceleration is positive or negative. And that's going to depend on whether or not these numbers, when subtracted, give you a positive number or a negative number. We will do a lot more of the problems and in talking about the equation in class. So it's not something you have to worry about right now. We just want to make sure that you get the concept of how we can have a positive and negative acceleration using our motion graphs. They really help to understand that.